Hi, this is Chris Schomburg, your instructor, and I'm going to talk with you a little bit about how a potentiometer works. And so a potentiometer can also be called a pot or a variable resistor. Essentially, that really is what it is. It's a variable resistor. It varies the resistance depending on your turning the knob. Now, they're used a lot. For example, in radios, we turn the knob to turn on or turn off the station, to change the stations in our cars, or wherever the radio is. Lights, you've probably heard of a light dimmer. That's exactly the same thing. You've probably turned off an old TV, and in doing that, you can actually change the stations that way too. So all of these are examples of where we've seen a potentiometer, and we're going to learn how to actually use one in application. Now, the first thing that we're going to do is we're going to go ahead and we're going to rotate our battery right here. Now, I always start with a battery in this case, and I always start with a battery as a positive and a negative rail. So if we look here, our positive is always red, and so we should see that that's red right there, and then our negative is always black. Okay, so we should see right there that that can then be black. Okay, I'm using Tinkercad. It's a great space. It's a very powerful CADing software. In fact, when I was going through school, they had really expensive CADing software called AutoCAD and things like that, and that was very like several $1,000s, and this is way better than that, and it's even free. So that's kind of amazing to me. Just the differences in a few years, what will actually happen. Okay, so we are going to actually use a resistor. We learned about resistors last time. We're going to use a 100 ohm resistor. Now this time, why we're using 100 ohm, which is something that we haven't used before, is because we're wanting to do something with a little bit less resistance. We don't really worry about the resistance as much because the potentiometer is going to adjust the resistance itself. And typically a potentiometer is about 100 ohms. So we're matching the impedance. So this resistance, when I say impedance, I mean resistance. This resistance is the same as this resistance. So what we're going to do is we're going to go ahead. We have the power in, right? We have the 9-volt battery. We are going to want to power a resistor. So I'm going to actually rotate this resistor. This is the 100 ohm. And I'm going to put it in 10. I'm going to put it on the end of 10 on E, and then on the G of 10 on this side. So then I'm also going to want to have this LED work. Now we know that this right here is negative. So remember, the flat side is the negative side. So we're going to have to rotate this until that flat side shows. There we go. So now I'm going to actually put this right here, which is on H, and that's H9 and 10. So it's now connected to this resistor here. And then we want to connect this line right here to the black, okay, the black line, which is the rail that goes down this way. And so we're going to actually call this one black, okay? So this color is now black. Now I could actually do that a little fancier, so I'm going to do it a little bit fancier just because it's easier to see. So I'm going to delete this, and I'm going to go from here. Now this is connected to the same spot as the resistor. This right here is 9, so the flat side is right here. We can then go straight across, which I like a lot better, to be able to go straight across because it looks nicer. It's cleaner. You don't have to cut the wires as much, and that looks good. Now, we're not a complete circuit yet. We have to actually have something in here to complete the circuit. So let's just, I'm just going to do complete the circuit first, and then we're going to add our other element next. So the next thing that I'm going to do is I'm going to go from here to the red right here. Now this is what we did last time basically. Let's see if it works. Yep, it's lighting the LED. It is a little too bright. It's actually going to probably burn out in this case. But now what we want to do is we want to put in a matching resistance, which is, we can change it to 250. This is 250 kilo ohms. So we're going to change it to 100 ohms. Okay, so now it's the same resistance as this one. And then what we're going to do is we're going to actually put it in here instead of this, let's actually put it in here instead of this red line right here. So this red line we're going to take out for a moment. Okay, we're going to rotate this because we want to only use, typically with a potentiometer, you're going to use the bottom, I apologize, you're going to use the top one and the middle one. You could use the bottom one and the middle one too, but you have to use just 2 of the 3. So in this case, what we're going to do is we're going to use the top one and the middle one. And I'm actually going to set it off like this because usually you extend these wires a while so that you can actually use them for other purposes later. But so I'm going to connect this directly to the red line right there. And we're going to connect that to red. Okay, so that one is going from the red, from the 9-volt battery, positive 9 volts, is going right into my potentiometer. Then I'm going to go ahead and I'm going to click right here at the wiper, which is the center one. I'm going to click that, and then I'm going to actually go to the other side of the resistor in this case. So if we go right there to the resistor, and I guess I could do this one as red. It's not really directly 9 volts. It's actually going to have a voltage drop. So I'm going to actually do it as orange. Because right here we have red going in, red going in. We know that's 9 volts. It goes through the potentiometer. It's going to come out a little bit less voltage-wise than before. So why I'm doing that is just to designate that, hey, we did have a voltage drop here. It's then going to go into here. Then it's going to drop right here, go through the light, and then should go to the ground, and then we have a full circle. Let's see if it worked at all. Okay, so it did work. And we're not really seeing what I was hoping we would see. So let's think a little bit about this a little bit more. Okay, so really typically, let's move our resistor over. I think that might be our issue. So let's go back and let's move our LED. So we had the LED right here. Okay, so I'm going to put it on the same line right here, and it's going to come in to the LED, to the circular line. Okay, and then let's go ahead and let's move our resistor back here. Okay, now I have too many things going on too close to each other, so it's a little bit funny right here. So I'm going to actually move this all the way over, and now we can see that when we go in, the 9 volt comes in, it goes down the rail, it goes to here, it goes to the potentiometer, then it goes to the circular side of the LED through this line right here. Then it goes through here, through the LED, through the resistor, and then down to ground, and then back to the battery again. So that's a full circle. Now let's actually start it. Okay, and let's see if we can see anything. I'm wondering if it's not the issue that I thought. It isn't. So I think what the issue is I think these resistances are too low. Now in reality you would have actually been able to see something there, but this is a virtual space. It's not always perfect, and it's not always going to really show what actually happens in real life. So let's go ahead and let's change this resistance to 1K. Remember, 1K seems to work really good in this with a 9-volt battery. So we're changing this to 1K. And in addition, we're going to change the resistance right here to 1K. We're going to match these two. We call that matching the impedance. We're going to impedance match. So this impedance is the same as this impedance. This resistance is the same as this resistance. That's all I'm saying. Okay, now let's go ahead and start. Okay. Okay, I'm not actually seeing what I was hoping I would see. I should see some dimming of the light, and we're not actually seeing it, which is really kind of unfortunate. So let's actually look a little bit more into this. Maybe this is more difficult than I thought. We know it's getting power, so we know that's working, right? But somehow this function is not working properly. So I'm going to go ahead. I know it's silly, but I'm going to go ahead and put this at 250 kilo ohms. Again, this will be weighted more than this resistance, so this should be a higher resistance than this one. Maybe that'll do something. So actually, I think two parts. I think one part is the computer is not working as well as we'd like. Also, the virtual reality isn't working as perfect as I would hope it would, but we do see if we reduce it all the way down, we see almost minimal light. And if we put it, or sorry, if we put it at its highest setting, sorry, I apologize. This is at its highest setting, we're going to see the minimal amount of light. We know that from last time. So this is the highest resistance. This is about 250 kiloohms. We're seeing this minimal amount of light. And if we go to its lowest setting, which is then just going through this 1K, we're going to see the brightest setting, which is the light right there. Now there's two ways to make this more extreme and more interesting. One way, remember when we impedance matched, we didn't notice any differences? Well, one way we could do is we could actually, like we did, increase this potentiometer resistance. And typically what they are is they can be up to 100 kiloohms. That's typically what most of them are that we'll find in labs and things like that, just because they're easy to come by. But we can also, so I'm reducing this so that now we shouldn't see it as much. So let's just test that theory. So if I go like this, yeah, we still see it. So we actually still see it lighting and we still see it fading, right? That's pretty good. But the other thing we could do is we could reduce this back down to its original setting, which was the 10 ohm or 100 ohms. And if we want, we can get a little bit crazy and reduce it down to 10 ohms, but for now, we're going to go down to 100 ohms, okay, which is brown, black, brown, gold, okay. We're going to hit start. Yeah, see, now we're actually seeing when we go all the way to the lowest resistance, we're actually burning out the LED. And I can actually show this more dramatically. Let's just make sure that we can see this. So if we turn this back into, instead of 100 ohms, we go into 10 ohms, which is almost minimal resistance. That's like almost nothing. It's like almost putting a jumper, which is what we'll do next. Okay, so we'll start there, and you see it's actually bursting. It could actually burn up. So that's not what we would want, but it's good to see here that we're seeing a difference by reducing this resistance. So you could reduce the resistance here, or you could reduce the resistance here. Typically, these come pretty standard and you can adjust them, right? And so that's kind of a nice thing about it. But typically, they come pretty standard and they're typically 100 kiloohms resistance to 10 kiloohm resistance. So you start, that's kind of your maximum is 100 kiloohm. Your minimum is, like a 0 or minimal resistance. And so there's two things I want to show you. One is, wow, that actually burned out, right? So let's say we delete this resistor and we actually just put in a jumper. And I'm going to put this in purple, okay? Because we now know it's just a jumper. It's literally just going straight through, just like as if there was nothing there. No resistance at all. Just like if you're turning on a valve, you open it up to the largest largest valve possible that you can do, and it's just going straight through. There's nothing slowing it down. So let's go ahead and start this. Okay. So if we go down to the highest setting, we have a minimal resistance, a minimal light. If we go to the lowest setting, we're actually seeing a very bright. Again, this is saying that's 859 milliamps, which was above the 20 milliamps guidelines. So that's kind of cool. So the jumper actually did what we thought it would do. Okay, let's actually go one step. I know it's like take one step forward, 2 steps back, it seems like. But what we're going to do here is we're going to go back to that 10 ohm, and I want to just read the value. And we can kind of see the difference. So if we go here to the ohms, we go 10 ohms, and see now we can hit this and we can see, well, we're at 384 milliamps instead of the 20 milliamp guideline. And so then again, take 2 steps back, 384, I'm remembering that, 384, 384, what are we now? We're at 859. So there is a difference in milliamps. So there is a difference between a jumper and actually a 10 ohm. So it is good to have resistance no matter what, even if in both cases you're going to have the same result. It's good to have some form of resistance. So typically we go with a 1K. Okay, so we'll do that. The other thing that we can do is we could do a jumper here. Okay, so we know here this is a 1K right here, and we know that a 1K actually will be fine if we jumper it with minimal resistance. So we can see here we're not seeing a light that's burning out with the 1K. So let's go ahead. I'm going to actually, and it's nice because you can see that it's actually dimming and lightening here. I'm going to actually take out my potentiometer. So I'm going to have to stop. I'm going to take this out. Okay. And then we're going to go from here directly to here, right? So that's 9 volts. So we're going to do that one as red. Okay. And then, yeah, that's it. So it's like we're jumpering it. So we're not actually using the potentiometer. And let's see here. Oh, I was silly. Sorry. We wanted to go from the same rail. So we can go right here to here. So we need to actually put that in as red right there. We start that up, not there. I'm nearly silly, sorry. Go from here to here. There we go. So we always want to go to the round side for the positive and the flat side for the negative. There we go. So notice, because we have the 1K, we're not going to have the exploding LED. We're not going to have the burning out LED. It's really important to note that. Now, okay, so let's say I shorted it, and in this case I used my 10 ohm. Again, I'm going to extreme measures here. Now what happens? Okay, and again, we're going to explode here too. So again, it's really important when you reuse resistors, especially in these kinds of labs, you always want to use something above, if you're exploring things, start with the 1K ohm resistor. That's perfect for this kind of circuit. It's going to work perfect. Okay, so let's go back to our remnants of what we were working with, just to show you kind of what I would recommend as guidelines. So, as guidelines, I would always recommend a 1 kilo ohm. Okay, and then I would recommend we rotate this. And then you're going to always use the top and the middle wiper. So the top one is going to go directly into power. So we're going to go like right here to power. Okay, that one's going to be red. Then the next one is going to be orange. And we're going to go right to here because that's in the same line as that circular part of the LED, right? And so that's going to actually power it up. So if we start this now, we are safe even at the lowest level of the potentiometer, and we're safe at the highest level. So that is perfect, and we're seeing a high and a low. We're seeing the dimming quality to that. Now you'll actually see more of an intermediate stages in reality. It's not really showing it too well with this virtual design. So that's kind of some of the limits with virtual designs. They are okay, but they don't do differential equations. They don't do anything really above just kind of on or off. They have a hard time doing dimming, and so this is hard for them to actually show in reality what's happening. Okay, so at this point, I am going to pull out my mouse, and I am going to go ahead and I'm going to put in my drawing. Okay, so you can see I have a tablet right here. I'm going to go ahead and I'm going to draw a little bit here. And I'm actually going to draw the circuit, symbolical circuit that we have here. So you have actually seen really a couple things that I want you to know is that the battery we've seen before. So we see that we have something that looks like this. Oh, sorry. Well, let me draw that a little bit better here. So we go long, short, long, short. Okay, and so basically this right here is the positive end. This right here is the negative end. That represents the battery. That's this 9-volt battery. That's what it represents. Okay, and then this goes back into a resistor. We're going to be a little fancy here. We're going to actually call this resistor R2. And we're going to actually put in a variable like the wiper that we can move and rotate to change and dim the lights. Okay, then we're going to go off of that wiper. Okay, we're going to go ahead and we're going to label an LED. So really a functioning LED looks something like this. And then we have a resistor. Okay, so we're almost done with everything. Okay, so typically when we have an LED instead of a diode, we draw these arrows designating the light emitted from them, a light emitting diode. So this is our LED, light emitting diode. So this is the diode, this is the light, and then this is emitting. So hopefully that helps you remember. This right here is our potentiometer, or pot. Okay, and right here, so this potentiometer is right here. That's the potentiometer. These are both potentiometers. This is the wiper at the center. Okay, and then this right here is our battery. Okay, so this is our 9-volt battery. All right, so we've labeled all of them. We've gone ahead and talked a little bit about them. I'm going to take a little bit more time and kind of talk a little bit about the different wipers settings. So typically you can actually have, so there's like really what I would consider 3 settings. So if we have this as a resistor right here, like that, and then we actually put a wiper in it, okay, and we call this A, we call this B, we call this C. Now typically potentiometers are equated as 100 kiloohms. That's what you find easy at hand at most labs that you look at. Okay, now let's go ahead and write the 2 different really situations. And then this is C. Okay, so what I'm going to talk about real quick here is the 2 different positions of C. So C could actually be way up here, or it could be way down here. Okay, now in this case, if it's way up here, this is corresponding to a 0 value. Okay, and actually let me not put the parentheses. I know they're free, but I'm not going to put the parentheses in. I'm going to use a different color for the values. So let's go ahead and actually put in kind of a violet color. This right here is 0. Okay, and this right here is 100 kiloohm. Okay, so typically, remember when we move this all the way up to this point right here, when we move the wiper, this would be the wiper at A. Okay, and this right here would be the wiper at B. So remember when we moved, and I'm going to do another color just because it's good to have colors. So we're going to go orange. Okay, so when we moved it all the way to A, which was all the way up here, we had almost 0. Okay, so this is the position at A. We had a 0 resistance here. If you remember, the light was really brilliant. Okay, and if you remember, when we put the position at B, the light was very dim. So we had really almost 100 kiloohms resistance, which is the highest resistance the potentiometer can give us, and then what we had was very dim light. Okay, so we've talked a little bit about potentiometers. We talked a bit about how they work, what they do. They basically just change the resistance. They vary the resistance in by the amount that you twist on each one of them. So the amount you twist on the potentiometer will either give it 0 or somewhere in between 100 kilo ohms. Typically, that's what most of them are rated at. Okay, so we've learned about variable resistors. We've learned about how they're used. We know their applications are in radios, TVs, and even in dimming lights. Okay, so I hope you keep looking at some of these labs, and we'll continue doing these in the future.